In this video, I'm going to talk about the Monty Hall problem, as well as the solution to this problem, or at least one solution to this problem. It really depends on which way you look at it. So if you're not familiar with the Monty Hall problem, it's based on a game show. So I've just sort of set something up here. It's a game show based on 3 windows. So a contestant would select one of the windows, the host would reveal one of the windows, and one of the windows would contain a winning prize. So there'd be a winning window, and the other 2 windows would be losing windows. So the way it goes is that the contestant would then pick a window. The host would then reveal another window. So let's say, for example, I'm a contestant. I might pick window number 1. The host would then reveal either window number 2 or 3. And then based on the outcome of what's sort of behind windows 2 or 3, the host would then ask the contestant, would you like to switch your choice? So let's say, for example, I pick, let's say, window number 1 as a contestant. So if it's red under window number 1, it's lose. If it's green, it's win. So let's just say then that the host, would then reveal, let's say, window number 3. So, that's a losing window. The host would then ask the contestant, myself, what would you like to do? Would you like to stick to your choice of window number 1, or would you like to now switch to window number 2? So the Monty Hall problem is, what is the best decision to make here? What decision should I make as a contestant to maximize my chance of winning the grand prize? Now, there is an assumption here, and I'm going to state this assumption here, that the host knowingly reveals a losing window. And I know there's lots of theories on the Monty Hall problem, and there's heaps of videos out there, and there's heaps of different theories. But the theory that I'm going to talk about assumes this, that the host knows what is behind the remaining 2 windows. And alongside this assumption, the host knowingly will not reveal the winning window. We'll pick one of the losing windows to reveal. So the question is, do I switch? In other words, do I then pick, say, for example, window number 2? Or do I remain with my current choice to then maximize my chance of winning? So most theories, in fact, all theories that I've seen so far will say you should switch. So for example, I should switch from window number 1 to window number 2, and that will maximize my chance of winning. So why is that? And so what I've done here is I've just written the theory just to make it a bit easier to explain. Why is it that switching increases your chance of winning? So now I'll go through these points briefly. So before the host reveals a losing window, okay, we can agree that we have a 2/3 chance of losing with your current choice. So I picked window number 1, for example, if you remember, I picked window number 1. I've got a 1/3 chance of winning, 2/3 chance of losing. Okay, so there's 3 windows there. Now, after the host reveals a losing window, now remember our assumption. The assumption here is that the host deliberately revealed a losing window because the host knows what is behind the windows. So there is a 2/3 chance still that your current choice is a losing window. That hasn't changed. So in other words, one of the windows revealed by the host was a losing window. There's a 2/3 chance that the window that I've currently chosen is a losing window. But the host had kind of done me a favor by saying, well, the other window is a losing window. You've still got a 2/3 chance that the window you're on is still a losing window. So this means that the other remaining window must have a 2/3 chance of winning. So therefore, switch windows to maximize your chance of winning. So I hope that makes the theory sort of easier to understand as to why switching is the better option. But again, it is based on that assumption that the host deliberately reveals a losing window. Thanks for watching, everyone.